इस वीडियो में जीएसआई प्रीलिम्स 2023 जियोफिजिक्स पेपर के आंसर की और उनसे रिलेटेड डिस्कशन मैं करने वाला हूँ. So the first question is here. The brittle deformation is the main mechanism in tectonic process it involves. तो इसका जो आंसर होगा वो मोस्ट प्रोबेबली ये होना चाहिए, बट इट्स देर इज़ अ लिटिल कन्फ्यूजन, तो मे बी बी भी हो सकता है, बट इफ़ यू गैस द आंसर इज समथिंग एल्स. सो the next question is the branch of geophysics which deals with the Earth's geometrical shape, orientation, mass distribution, and their variation with time is known as its geodesy. और आप इसका रेफरेंस मैं आपको दिखा सकता हूँ. You can see in here now that Earth's shape and gravity are intimately associated. In the figure of Earth is the shape of an equipotential surface of gravity, and all this observation, whether shape of Earth, orientation of polar axis, all this comes under the science of geodesy. So coming to the next question, which of the following Kepler's law is the result of conservation of angular momentum? सो कैपलर्स लॉ, द फर्स्ट लॉ होता है वो कंजर्वेशन ऑफ एनर्जी होता है, देन द सेकेंड लॉ इज कंजर्वेशन ऑफ एंगुलर मोमेंटम. सो द आंसर वुड बी बी. कमिंग टू फोर्थ क्वेश्चन, विच ऑफ द फॉलोइंग पेयर्स ऑफ प्लैनेट्स डज नॉट हैव एनी नेचुरल सैटेलाइट्स. सो इसका जो आंसर है वो मरकरी और वीनस होना चाहिए, बिकॉज इनकी कोई नेचुरल सैटेलाइट्स नहीं होते हैं. मार्स की फोबोस और डिमोस हैं. सैटर्न के अपने नेचुरल सैटेलाइट हैं, जैसे अपने मून है, टाइटन है, और यूरेनस के भी बहुत सारे, यूरेनस के सबसे ज़्यादा नंबर ऑफ नेचुरल सैटेलाइट्स हैं. सो द आंसर वुड बी फर्स्ट. नाउ कमिंग टू द नेक्स्ट क्वेश्चन. सो टाइडल करेक्शन इज हेयर, ड्रिफ्ट करेक्शन, फ्री एयर करेक्शन, इटवॉस करेक्शन. आपको ये सारी चीज़ें मैच करानी है. इटवॉस करेक्शन को आप देख लो. इटवॉस करेक्शन इज़ बेसिकली ये यूज़ होता है फॉर स्पीड ऑफ एंड डायरेक्शन ऑफ मूविंग व्हीकल कंटेनिंग ग्रेविमीटर. फ्री और टाइडल करेक्शन आप जो ग्रेविटेशन इफेक्ट आता है अर्थ के, सन और मून के वजह से अर्थ पे. और ड्रिफ्ट करेक्शन होता है जो ग्रेविमीटर में टाइम के साथ क्रीपिंग होती है, उसकी वजह से जो चेंजेस आते हैं रीडिंग्स में, तो ये होगा. और फिर फ्री करेक्शन, ये सी का 4. सो दिस इज हाउ यू हैव टू मैच, एंड द आंसर वुड बी
अबे जल्दी बोल, कल सुबह पनवेल निकलना.
and B का 1. So the answer would be A. Coming to next question. Now the ratio of centrifugal to gravitational attraction is maximum at the equator. What would be its value of if the radius of Earth is RE and the rotational angular momentum is omega? Mass is m, gravitational constant in z. तो आपको बेसिकली रेशियो निकालना है सेंट्रीफ्यूगल एक्सेलरेशन एट द ग्रेविटी एंड ग्रेविटेशनल एक्सेलरेशन एट द सेंट्रीफ्यूगल एक्सेलरेशन एट द इक्वेटर एंड ग्रेविटेशनल एक्सेलरेशन एट द इक्वेटर का रेशियो हमें चाहिए. तो वो जो रेशियो आता है वो आपका ऑप्शन सी आएगा. और इसके रेफरेंस की एक बार बात कर लेते हैं. द सेंटर ऑफ द रिवोल्यूशन ऑफ अर्थ मून पेयर. सो ये क्वेश्चन भी पिकअप किया गया है सेम बुक से एंड सेम चैप्टर, एंड द आंसर इज विद इन द अर्थ. द आंसर इज विद इन द अर्थ. सो आप ये टॉपिक पढ़ोगे So you will get the idea about that question. Coming to next, which one of the following rock have highest value of magnetic susceptibility? जो मैग्नेटिक ससेप्टेबिलिटी है वो बेसिक इग्नेस रॉक्स की बहुत ज़्यादा होती है। तो ग्रेनाइट बेसिकली एसिड इग्नेस रॉक्स है, और शेल और सैंडस्टोन सेडिमेंट्री रॉक्स है, उनकी मैग्नेटिक ससेप्टेबिलिटी काफ़ी कम होती है। तो जो राइट ऑप्शन है वो सिर्फ गैब्रो है, जो कि एक बेसिक इग्नेस रॉक्स है। इस और बेसिक इग्नेस रॉक्स की ससेप्टेबिलिटी सबसे ज़्यादा होती है। Coming to next question, which of the following correctly represent the geomagnetic declination, inclination and total field direction? So जो डिक्लिनेशन होता है वो एंगल होता है बिटवीन नॉर्थ मैग्नेटिक पोल एंड जियोग्राफिकल पोल। तो यहाँ पे आपको फर्स्ट में ये ऑप्शन दिखेगा और थर्ड ऑप्शन में आप, तो या ये ए हो सकता है या सी हो सकता है। और जो इंक्लिनेशन होता है वो टोटल फील्ड वेक्टर हॉरिजॉन्टल से कितना बना रहा होता है। तो जो टोटल फील्ड वेक्टर है आई वो जो टोटल फील्ड वेक्टर एच है वो हॉरिजॉन्टल से जो एंगल बनाएगा उसे इंक्लिनेशन कहेंगे। और यहाँ पे आप देखोगे सिर्फ फिगर ठीक, अगर आप टोटल फील्ड के वेक्टर जो कि यहाँ पे टी है, तो यहाँ पे वो हॉरिजॉन्टल से आप देखो सिर्फ ऑप्शन सी में वो आई एंगल बना रहा है। तो इसका ऑप्शन सी इज़ द राइट आंसर। कमिंग टू नेक्स्ट क्वेश्चन, द सब्सटेबिलिटी ऑफ पैरामैग्नेटिक मटेरियल। तो जी हाँ, जब हम किसी पैरामैग्नेटिक मटेरियल को अगर हीट करेंगे तो टेम्परेचर बढ़ेगा, तो उस केस में उसकी सब्सटेबिलिटी डिक्रीज़ करेगी। तो डिक्रीजेज विथ इंक्रीज इन टेम्परेचर। द इक्वल वैल्यूज ऑफ लेम कांस्टेंट लैम्डा एम फॉर मटेरियल मेक पॉइजन रेशियो 0.25। सच मटेरियल, जो भी पॉइजन सॉलिड मटेरियल होता है उसके इसमें लैम्डा और म्यू इक्वल होते हैं, लेम्स कांस्टेंट जिसे हम बोलते हैं। और आप जो इनका प्रॉपर फॉर्मूला है आपको मैं एक बार दिखा देता हूँ वो। सो यू कैन सी इन दिस वीडियो, in particular this page, the formula is sigma equals to lambda upon 2 lambda plus mu, and for ideal Poisson solid the sigma will be 0.25. When we put these values we will get lambda equals to mu, and this is the case of Poisson solid material. So मैं क्वेश्चन 6 के बारे में रेफरेंस देने वाला था और वो मैं थोड़ा भूल गया। तो ये जो क्वेश्चन पिक किया गया है वो लॉरी बुक से पिक किया गया है, और ये जो m होता है इसी को वो रेशियो बोलते हैं। तो ये मैं ओमेगा स्क्वायर ए यहाँ पे आप देख सकते हो, ये जो है ओमेगा स्क्वायर ए ये आपका हो जाता है इक्वेटोरियल सेंट्रीफ्यूगल एक्सेलरेशन, और जी ई अपॉन ए स्क्वायर हो जाता है इक्वेटोरियल ग्रेविटेशनल एक्सेलरेशन, और यही रेशियो आपसे पूछा गया था। तो फिर वो आ जाता है ओमेगा स्क्वायर ए क्यू अपॉन जी। ये आपका फिर जो ऑप्शन बनता है यहाँ पे थर्ड ऑप्शन बनता है। सो कमिंग टू क्वेश्चन नंबर 12, एट द फ्री सरफेस ऑफ अर्थ द एम्पलीट्यूड ऑफ एस एच वेव बिकम्स। देखो इसका जो आंसर होगा वो थोड़ा कन्फ्यूजिंग था, बट इसका आंसर मोस्ट प्रोबेबली 2 टाइम्स होना चाहिए। और मैं आपको एक दिखा भी देता हूँ एक रेफरेंस। So you can see here at the free surface the amplitude of SH motion is doubled. We call this multiplicativity factor for HS receiver function. Free surface receiver function of P and S waves involve comparable displacement amplification. तो जो मेन पॉइंट है the amplitude of SH wave motion becomes double. तो मोस्ट प्रोबेबली वो 2 टाइम्स होगा आंसर। क्वेश्चन नंबर 13 देखते हैं, द फेज डिले बिटवीन द स्ट्रेस एंड स्ट्रेन ऑफ मटेरियल इज 60 डिग्री, द क्वालिटी फैक्टर ऑफ द मटेरियल। ये डायरेक्टली बुक में तो मुझे नहीं पता कहाँ है, बट एक रिसर्च पेपर के थ्रू मैंने इसे सर्च किया तो मुझे इसका सॉल्यूशन मिला है, वो मैं आपको दिखा देता हूँ। सो जब आप एनालिटिकल रिप्रेजेंटेशन ऑफ विस्को इलास्टिक मॉडुलस पढ़ोगे तो ये आपको एक रिसर्च पेपर में मिल जाएगा। तो वहाँ से आपको ये पता चलता है दैट क्वालिटी फैक्टर इज़ इक्वल्स टू कॉट थीटा, एंड इस फॉर्मूले को यूज़ करके आप नेक्स्ट क्वेश्चन को सॉल्व कर सकते हो। सो जैसा कि यहाँ पे दिया हुआ है दैट फेज डिले बिटवीन द स्ट्रेस एंड स्ट्रेन ऑफ अ मटेरियल इज 60 डिग्री, दैट मीन्स हमें थीटा दिया हुआ 60 डिग्री, तो कॉट 60 इक्वल्स टू 1/10 60, दैट मीन्स इट इक्वल्स टू 1/√3। तो 1/√3 की जो वैल्यू आएगी वो नियरली आएगी, और वो वैल्यू आएगी 0.58। So most probably the answer would be D. Now coming to next question, when the undeformed strike is used as a reference, the Piola-Kirchhoff stress tensor is. So this was a completely out of the box question. तो इसका जो आंसर होगा, so here, so as I am not very sure about this question, so the answer would be for question 14 would be, as I have searched, is symmetrical only. But you guys may have a different answer with that. You can comment and let's have a discussion about that. Now, which one of the following seismic phases represent the P wave conversion into S wave during its passage through solid core? It's P, PKJKP, when the P wave velocity from outer core travels through inner core and is converted to S wave. We use the symbol J. So the phase would be PKJKP. Consider the following statement regarding hotspots. Hotspots. Consider the following statements regarding hotspot. Hotspot is a long-lasting center of surface volcanism and locally high heat flow. So that's true. Hotspots. That's a true option. And the hotspot occur only in oceans basin, not in continents. That's not true, because there is a hotspot, Yellowstone hotspot, which is a continental hotspot. So this statement is a wrong statement. The ocean hotspots are found in conjunction with interpolate hotspot. This is a right statement. And hotspot creates a mass and only this also. You can also eliminate that second option is wrong. So the only option that can be correct is option C. Now, for the surface wave propagation, which are the following relations among the group velocity, phase velocity, and wavelength and frequency? So this was quite easy question, and it's those who have studied the formula may have answered that. The option would be here right is first one, and they have asked this question from book Lorry. So coming to next question. For 17, the answer is A. Okay. So for the next question, which of the following equation utilized for modeling the density variation with depth inside the Earth? So Gardner equation is basically told you the relation between the p wave velocity and density. So that would not be the answer. So for this question, the answer is Adam-Williams equation. It shows the variation of density with depth, because the Gardner equation is just shows the variation of density with p wave velocity. So that not would be the correct. And Conal and Poisson equation basically out of this, they cannot be true here. The only option can be true here is option A. Now, which of the following types of triple junction is always stable? The reach triple junction is always stable. So the answer would be D. Now, mid-oceanic ridge basalt is produced as, so mid-oceanic ridge basalt is produced when the oceans are separated, continents are separated, and a new lithosphere is created, and that happens at constructive margins. So the answer would be C. Now, which of the following statement regarding the velocity of tsunami is correct? So there was a confusion because it was a people may have done wrong. So when the tsunami approaches the seashore, so its height increases because the mass behind the wave, they got built up, and the amplitude, or you can say height of the wave increases, but the velocity slows down. So in that case the answer would be A. Now coming to the moment of inertia, sorry, the coming moment magnitude, and you have to use the formula here, and which is 2 by 3 log m naught minus 9.1, and you have given the seismic moment, and you just have to put it in this formula, and you will get the value as 7.23. Now coming to question number 23. Now इस क्वेश्चन को सॉल्व करने के लिए you just have to see which equation satisfies this point 1 2 minus 1, and the question which satisfied is this one and this one, but the A cannot be the right answer because it is the same equation which is given in the question. So the only probable answer is C here, C1. Let's see next one. Now you have to, in this question you just have to put all the values del dot A, and just you have to integrate it, and the answer would be is D. Here again you have to multiply, and the bracket here is basically, when you open the bracket you will get my mx minus mx my, and you have to multiply those matrix, and you have to subtract it, and the answer here you will get is A. Here in this question, it has asked what is the determinant. The answer would be 24. And if I see the previous question, there were three matrices in given. You have to find my mx. The bracket here means that when you open it, you will solve it, and you will get my mx minus mx my. You put those matrix and product of those matrix, and then subtract it, and you will answer the you will get is A. Okay, and this one was already discussed. Here the answer is 4. Here the and 26, the answer is 24. You have to find the determinant. And coming to question number 27. Into question number 27. So here the question is want you to calculate the work done, and the magnitude of force is given as kr, and where r is under root x square plus y square. So the solution of this question will be, so you can see here what is given to us, F equals to KR. Now if we have to calculate the work done, so the formula would be integral FDR. Now if I put the value of F which is equals to KR, so this I have put in the value, and I will get key r square by 2. And what is r here? X square plus y square. And if I see 1 plus 4 by putting the values of x and y, I get under root 5. And now if I put here in r square by 2, I get 5k by 2. So this would be, I think, the right answer. Now coming to question number 28. What is given here? A comet A moves in an elliptical orbit, and uh, it distances from the sun at perihelion and aphelion is given. Okay, so it is asking about the same imager axis. So what is given here, let me tell you. See in this figure. So what is given here? It is in this question what is given to us is the value of AE plus A, and I think the next one is AE No, actually not. Let me do it again. What is given to us is what is given to us is a plus ae, and a minus a is given to us. Okay, you just have to add these values and you will get the answer. Let me show you the solution. See here, so a minus a is given to you, which is a distance at the perihelion. Okay, let me show you again the figure. See this distance at perihelion, the distance of a comet from the sun at perihelion would be ae plus a, and at aphelion it would be, one second, sorry for that, at perihelion the distance would be uh, a minus a. You can see here this whole line is a, so a minus a would be the distance at perihelion, and at aphelion the distance would be uh, a plus a. So this is what is given in the question, and we have to solve this. So here just giving the values and just add up, a and minus a plus a will be cancelled, and after adding you have to like be careful that it is 10 to power 9 here and it is 10 to power 7 here. So if you add this you will get this, and after dividing the value of semi major axis you will get this. So the answer would be, B. Okay, now coming to next question. There is a question: imagine a potential VR equals to c square upon r minus r, and VR is used to drive a conserved force. See the if I have to answer this question, I am not very sure about this, but since it is talking about conservative force, for example, gravitational force is the conservative force, and gravitational force is always attractive. So in that case, if we see from this perspective, the answer would be a. Which of the following is true? Coming to next question, which of the following is true for the ranges of forces? A strong force is a long range. No, a strong force is a short range force. This is wrong option. A strong force is a long, again this is wrong option. Electromagnetic force is a long range force. That's true. And short range is short force. Strong force is a short range. So that is the correct option. C1 is the correct. And electromagnetic force is long range. That's true. Gravitational force is short range. No, gravitational force is also long range. So again this option would be wrong. So only C option is correct. Now let's see the next question. Now, an object of mass 2 kg collides inelastically with another object of mass 8 kg, which was initially at rest. The two objects stick together after collision. Then the ratio final to initial kinetic. Then the ratio final to initial kinetic energy. It has been asking. See, how will you solve this question? It's very easy question. Now coming to next question. In question number 33, this is a clear-cut formula. Those who have remembered the formula have correctly answered this question. The answer would be B, half mr square, because it's asking the moment of inertia for solid cylinder, and this is clear-cut half mr square. Now, number of degrees of freedom of a rigid rod. So in case of a rigid rod, the degrees of freedom will be 3, most probably. I'm not sure about this one, but I think 3 is the answer. Now coming to question number 35. In 35 you just have to use the formula T equals to T naught upon under root 1 minus V square upon C square. That is what you have to use. So here you just have to put the all values of whatever given, V is given to you and T naught is given to you. You will get the answer as 4.2 into 10 to power 10 to power minus 8 seconds. Okay, coming to next question. Again here, what you have to do, the percentage of contraction in the length. So here previously it was talking about time dilation, now it is talking about length contraction. So in case of length contraction, the formula is given here. L equals to L naught under root 1 minus v square upon c square. You have to put the values, and when you it is asking about the percentage contraction, so the percentage will be L naught minus L upon L naught. So L naught, you have, if you will put the values and you will get 40 as answer. So remember this formula basically. Galilean transformation. So for Galilean transformation, this will be the option D. Very easy question. Now the sensitivity of geophysical method is determined by, the sensitivity of geophysical method is determined by basically the ratio of norm of perturbation in the data to the perturbation in the model parameters. Uh, in this question, what is the standard deviation of mean? So if I will show you a figure, this will give you some idea about this. सो फ्यू क्वेश्चंस स्किप हो गए थे, उनको फिर से डिस्कस कर लेते हैं. जैसे क्वेश्चन नंबर 31. सो हियर एन ऑब्जेक्ट ऑफ मास 2 kg कोलाइड्स इन elastically with another object of mass 8 kg which was initially at rest. The two objects stick together after the collision. Then the ratio of final to initial kinetic energy after collision, before collision. So let's see the solution of this.
तो 2 kg का मास है और 8 kg का मास है. 8 kg वाला मास इनिशियली रेस्ट में, मतलब यू इक्वल टू 0 उसका. द टू ऑब्जेक्ट स्टिक टुगेदर आफ्टर द कोलिजन. तो जब दोनों स्टिक कर जाएंगे तो जो टोटल मास होगा एक ही ऑब्जेक्ट का हो जाएगा 10 kg. देन द रेशियो ऑफ फाइनल टू इनिशियल काइनेटिक एनर्जी. तो पहले हम इनिशियल काइनेटिक एनर्जी निकालने के, मान लीजिए कि 2 kg वाले का वेलोसिटी भी है, तो उसकी काइनेटिक एनर्जी हो जाएगी हाफ इंटू एम भी स्क्वायर प्लस इसका इनिशियल वेलोसिटी 0 है 8 kg वाला का, तो उसका काइनेटिक एनर्जी 0 होगी, इक्वल टू फाइनल काइनेटिक एनर्जी होगी हाफ इंटू मास यानी 10 इंटू वेलोसिटी स्क्वायर. तो 2 से 2 कट गया, भी स्क्वायर इक्वल टू 5 भी स्क्वायर. ठीक ना. रेशियो ऑफ फाइनल टू इनिशियल काइनेटिक एनर्जी. तो इनकी काइनेटिक एनर्जी का रेशियो क्या हो जाएगा, देख लीजिए.
सो इनिशियली यहाँ पे 2 kg का मास है और 8 kg का मास है, तो 8 kg रेस्ट पे है तो उसकी वेलोसिटी 0 हो जाएगी. और पहले की मान लेते हैं वेलोसिटी v1 है, तो 2 इंटू वी वन, 2 इंटू वी वन, ये आप देख सकते हो 2 इंटू वी वन, ये वाली लाइन, प्लस 8 इंटू ज़ीरो प्लस इक्वल्स टू 10 इंटू वी टू. क्योंकि जब वो स्टिक हुए टुगेदर तो उनका मास जुड़ जाएगा. तो इस केस में हमें वी वन इक्वल्स टू 5v2 मिल जाएगा. अब हम काइनेटिक एनर्जी के टर्म्स में देखते हैं इसको. तो फिर यहाँ से इनिशियल काइनेटिक एनर्जी हाफ एम वी स्क्वायर, विच अभी मास 2 kg है, और फिर सेकंड के लिए तो वेलोसिटी 0 है, तो 2v1 निकल गया. और फाइनल काइनेटिक एनर्जी आ गया हाफ इंटू 10 इंटू वी टू स्क्वायर, मतलब 5v2 स्क्वायर. तो फाइनल अपॉन इनिशियल का रेशियो आ गया 5v2 स्क्वायर अपॉन v1 स्क्वायर. और v1 स्क्वायर की वैल्यू आपको यहाँ से फर्स्ट इधर से मिलेगी 5v2, ये आप देख रहे हो. इसी को फिर यहाँ पे पुट करना है, तो फिर ये आ जाता है 5v2 स्क्वायर अपॉन 25v2 स्क्वायर. तो 1/5 बेसिकली 0.2 आपका आंसर होगा. नाउ कमिंग टू नेक्स्ट क्वेश्चन, कंजर्वेशन ऑफ लीनियर मोमेंटम. तो इसके बारे में मैं आपको कुछ दिखाना चाहूँगा. So I want you to read these lines. So we have to remember that the momentum of system is conserved and not that of individual particles. Okay, not that of individual particles. Remember this. So the moment of individual bodies in the system might increase or decrease according to the situation, but the moment of the system will always be conserved. ओके, क्लियर हुआ एक चीज़ यहाँ से. Also see here, the momentum of a system of particles is conserved as long as no external force act on the system. And why this? Because any internal forces are in interaction between the pairs of particles, and those forces are always equal and opposite. So cannot change the momentum of the system whether the internal force are conservative or not. सो दैट डज़ नॉट मैटर. तो इसके हिसाब से ये जो मैंने चीज़ें दिखाई उस हिसाब से तो आंसर होगा. सो जो आंसर बनता है यहाँ पे वो ये बनता है कि डज़ नॉट इंश्योर द कंजर्वेशन ऑफ इट्स कंपोनेंट. तो ये तो फर्स्ट ऑप्शन में है और थर्ड में भी है. दूसरी चीज़, एंड इट्स वैलिड इवन व्हेन द इंटरनल फोर्सेस आर नॉन कंजर्वेटिव, and it's not valid in so the C option would be wrong. So the first option is correct, does not ensure the conservation of its component, and it's valid even when the internal forces are non-conservative. Okay, let's see the next question. So I've already discussed these questions. Okay, so coming to next one. 36 was also done. 30, 37, 38, they have been discussed. Now coming to 39 question. So Poisson distribution reduces to binomial distribution. So in that case, see, when the value of n in a binomial distribution is large and the value of p is very small, the binomial distribution can be approximated by Poisson distribution. Okay, so in that case the answer would be, so the answer would be the number of trials should be large and the probability of the success should be small. So the option which is here correct is the number of trials is large and the probability success of Guinness trial is small. The answer would be D. Okay, those who have marked D, their answer would be corrected. I have already discussed 40 question. Coming to 41, I do not know this question right now. I don't know what is the probable answer of this question. So let's see. I am skipping this question. Coming to question number 42. So what do you have to do in question number 42? Firstly, you have to choose at which dice the 6 will come. So for that, the first thing you have to do 5C3. Then after that it says the probability that 6 is thrown exactly 3 times. So for that the probability will be 1 by 6, 1 by 6, 1 by 6, and other 2 times the 6 is not thrown. So in that case the probability will be 5 by 6 into 5 by 6. So overall the answer would come 0.32 if you solve it. Coming to question number 42. So it was very easy question. You have to just put the values and you will find answer as a 99. 44. In this case the answer would come as C. 45. I'm not solving this question because these are very easy question. You have just to put the values and you will find the answer. 45 was also easy. Some of the solution is also you can see here, this portion. So the answer would come here as D. So coming to next question. Now coming to 46 question, it was again an out of box question. Most of people don't have the answer for that, but let me tell you the real answer for this. So what you have to do in case of Wronskian determinant. So in that case Wronskian determinant, whatever it is, so you have to find the determinant of value e to the power 2x and e to the power 3x and their differentiation 2 e to the power 2x and 3 e to the power 3x. So you have to solve this determinant and you will get answer as e to the power 5x. That would be the correct answer. So those who have might have guessed this question and take e to the power 5x, those answer will be correct. So now coming to question number 47. In this case stiffness of the spring is given and mass is given. We have to find the equation of motion. So generally if you see the if you see this relation, f wherever ma equals to k into r, so in that case the or k into x, whatever it is, so the x relation will come into k by m. So here k is value 700 and m is 7 kg, so the answer would be definitely 100x. But now confusion might have plus 100x or minus 100x, so but the answer would be here a. Okay, so I'm not solving this question particularly, but I have told you the method how the answer will come. Now coming to question number 48, I am a little bit confused about this question, but I confused about the answer, that it will be theta equals to pi by 2 or not. I'm not very sure about this, but according to me most probably the answer would be D. So if you see the Laplace equation, there is a term in the last, 1 upon r squared sin square phi, sin square theta, and del f upon del phi square. So if we put theta equals to pi by 2, then only the second term will come, this one. So from that logic, I think theta equals to pi by 2 would be the answer, but I'm not sure about this. 49. So 49, the answer would be first order, and it's non-linear, and equals to 0 is not given, so it will be inhomogeneous. So the B will be the answer. 50. So if we solve 50, so if you solve question number 50, fx equals to x square minus 3x plus 2 and f dash equals to 3x minus x square. So putting these values, see the formula is x n plus 1 equals to x n minus fx upon f dash x. So the answer would be so if we put the values here at x1, and we put the value n equals to 0, so x1 equals to x0 minus f0 upon f dash 0, and x1 equals to 0 is given to us, so x0 would be f0 upon f dash 0, so answer would come 2 by 3. So the answer would be, I think, A. Okay, coming to 51 question. See, in this 51 question you do not have to apply Simpson's 1/3 rule, because just you have to find the value of directly value of integral, and which could be e minus 1 by e. So you have to put these values, and the answer you will get it. You do not need to apply here Simpson's 1/3 rule, because the options are not very close. So you just have to find e minus 1 by e, and you will get the right answer. So the answer would come 2.36. So now the Runge-Kutta method are used to find numerical solution of ordinary differential equation. The approximation in the method uses this answer would be third. And now question number 53. See what you have to do in this question. Let me 1 second. What is the question? The question here is 53, and the solution would be, so suppose at point q, the at point x, from the q, the another third charge q is capital Q is placed. So overall the distance between q and to q is L, and so this distance would be L minus x. So for the net force to be 0, this the force on q and to q will be in opposite direction, as I've shown here. And just you have to solve it by this analogy, q upon x square, for force at q because of small q, and force at capital Q because of this 2q charge. So q upon x is equal to q into 2 upon L minus x square, and you will get the value of x as like this. So the option C would be the right answer. So option C is here is the right answer. No, in this question you can solve it by unit. So the correct answer would be A. Okay, so for this video let's stop here. In another video I will show you the overall solution of this. तो एट लास्ट मैं बस यही कहना चाहता हूँ कि
तो रुको जरा, सबर करो, बोला धक्का बुक्की नहीं करने का, आराम से लेने का।